magnet boots, and just put them on just to see the feel. They're kind of heavy. They're very heavy. Getting in and out of them, they're very heavy, so they're not a problem. Just shake it off and off my foot, and that's the internal. Okay, I'm rolling this around to make like a ribbon form all the way up, and then I'm going to do the one all the way down. This is a metal and aluminum wire at the bottom, so I'm going to do another ribbon right here, this kind down here. I'm going to do one under the boot, going that way in the wind there. Once I do one set, I can repeat it again, and repeat it again, and repeat it again. So this is 500 feet of wire, 500 feet, and the gauge is like two 16 gauge, two 14 gauges thickness, or 14, yeah, two 14 gauge thickness. 500 feet, so I'll do 500 feet here, wire, over and over, for my suspension linear solenoid. Then we'll go down here and do this part. See how this blends seamlessly in there? And we're going to make it like a ribbon. And I got aluminum at the bottom. What basketball field does this resemble? So under the boot, let me zoom up. It's necessary, just mostly the solenoid sense for the upper, the pull, the permanent magnet's upper. See this block right here, these blocks? This is facing, overlaying the entire shoe. So underneath is the permanent magnet. See those magnets right there? Ceramic magnets, rechargeable magnets. So here you have the magnetism, electromagnetism from the ferromagnetic. You got the copper diamagnetic. You got the aluminum permagnetic. And aluminum foil for the surfaces is permagnetic. They're only supposed to receive a DC, direct current charge. And they're supposed to be powered by capacitors. Each one is supposed to receive 2 pairs of capacitors. Each one phase wire is supposed to receive 2 pairs of capacitors. So that's 900 volts. 450 enumerate 900 volts. It's driven by an ultrasonic driver, which is a transducer driver for transducer cleaners. And it's for the output of the audio output connected to the capacitor. The voltage that the capacitor is able to take up the maximum is 450 volts. Okay, so the coil is on there. I got to phase the coil and into the capacitor and into the bridge rectifier. I have to apply another aluminum and iron wire up on top of it. Notice I have them parallel, so I want to sandwich between it. So I can flux the density, send the magnetic field down, flux the density, send the magnetic field up. And when I get a synchronous induced currents to flux from the calf and the upper body to push down and to move these permanent magnets upward into the ear. Okay, I added the PVC rubber flex. Rubber flex. I need a PVC jelly or sheet so I can cut it out, and I can use a hot gun to create like a horn around this area, and then fill it up with the rest of flexible rubber flex, and flex the PVC around here and down here, and stop it right alongside that cut edge of the fabric. So it'd be like a suction cup. This right here, I added the flex, so it's right now curing. I also added to the inductor wire alongside it. It's going to change to clear, transparent. I got to do this too, so I can allow oscillations for acoustophoresis, operating as a transducer, the way the permanent magnets are housed inside under the boot. So to repel away from it with the ferromagnetic material, this is iron, steel, then I also have aluminum now. And aluminum surface, as you can see, foundation with iron wire coil is in series following alongside the exterior. But the inside compartment, inside the cockpit, I have to put the PVC jelly here. I don't know if I'm going to put the thermoreactive glow liquid or magneto glow liquid within here. Glow powder. So I'll probably put it around the edges, because either way, if I do it, I will still have to cut into it and then apply the sprinkling of the powder, sodium powder around it. The idea is to get the light emitting and to use a current carrying jelly. So the rubber, I will also add a current carrying liquid fluid within the rubber, so that the conductive, when it receives a Hall effect, it'll be digitally it'll receive a charge in the flux and differentials through interceptive Hall effect coils that will be localized on the calf and in the shin area. And that will send a Hall effect to flux the density and to control the electromotive force of the thermoreactive glow liquid. And there's 12, I believe there's 12 colors in one on Amazon. And I can use that like a digital display. So use a display driver and connect it to an electrode output, which basically is the differential pinouts, which are the differential coils that sends the Hall effect here to transmit that into electromotive force to control the light and magneto light spectrum, so that I can digitally audit these things. I have to also add the modules, camera modules for this display electrodynamic space boot. So just give me a chance and I'll finish everything up. The rest, I'll tell you more about it.